Hello, my name is Alexis Coyad, and I'm going to be talking about the analysis of comparative science in the forensics field. So, comparative science is a discipline in forensics that aims to answer questions such as, do these two marks or items come from the same source? Forensic scientists in this field look for different characteristics on these objects to help answer this question. Now, the characteristics that they look for are patterns, shapes, marks, impressions that are left on objects or on surfaces. Some examples of evidence that can be analyzed in this discipline would be fingerprints, so that you would compare the fingerprint found at a crime scene, or tool marks, where tool marks can be compared to a tool that could have possibly been used at a crime scene. Firearm markings, where bullets are compared to a specific gun that was obtained from a suspect or from the crime scene. Or it can be shoe or tire impressions to see if the shoe or the tire impression matches the specific one found at the scene. So, comparative science helps forensic experts link a person or a specific object to a crime scene, or possibly exclude them as a source based on these physical characteristics. So, objectivity and subjectivity are used in comparative science to make judgments. So, objectivity refers to something that is able to be verified and measured and replicated by other examiners. It's like the facts about the object. And then subjectivity refers to the personal feelings or the personal experience that the forensic expert has encountered that has led to them to make a judgment or make a conclusion. It's about how they feel and their own opinion on what's true to them. So the thing about subjectivity is that each individual may have their own belief on what is right. So, for example, some people may believe that oranges are the best fruit, and some individuals may believe that watermelon is the best fruit. It is opinion based. It is based on their own interpretations and their own experiences. So, an objective take on this example would be that an orange is the color orange and watermelon is a red color. It's fact and it's able to be verified. So, an example of objectivity versus subjectivity would be when analyzing bullets or in ballistics. So, let's say a bullet was found at a crime scene and a gun was recovered from a possible suspect. Objectivity in this scenario would be the to identify and measure the marks that were found on the bullet. And this could be the grooves, the striations, and the marks that were left on the bullet when the gun was fired from the barrel. Now, the forensic expert would analyze the bullet and measure the marks using, the width, maybe the angle of these marks, and the length, how long the marks are, to kind of match it to the gun found on the suspect to see if it's a match. Now, these characteristics that are going to be identified and measured, they can be documented by photos. As we know, that's what we should be doing. Now, subjectivity of this example would be the examiner trying to determine if the marks and the grooves on the bullet match the firearm. So, the expert is going to determine whether they're going to have to determine if the bullet is in decent condition or if it's damaged in any way or distorted in any way. They're going to have to interpret the marks. These marks, they may interpret it a different way as other experts may interpret it. So the images below kind of give an example of subjectivity. So, objective, there's a tree. It's a tree. And the three individuals here, one thinks, oh, well, it is a tree. I see a tree. And the second individual is like, oh, I see an apple producing product, or an apple producing thing. And then this third individual thinks, money, 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 money. And, that's their own personal opinions, that's their own personal experiences, that's what they think. This image right here on the bottom right hand side of the slide shows a man. He's like, I believe what I'm reading, it's true. And then the other individual right here is like, whoa, slow down here, we don't have enough evidence. The evidence is incomplete. Let's not jump to conclusions yet. So they have their own interpretations of, what they're seeing, what they're viewing. So Using the ballistics example, one expert can say that, oh, this came from this weapon, based on the pattern and based on the measurements, while another expert comes in and is like, no, I believe it came from a different weapon because of these patterns, and that's where, different tests can be run. So when we're analyzing these specific types of evidence, we're going to be trying to observe any unique characteristics. So some unique characteristics that forensic experts may look for would be forms, patterns, and feature persistence. So form is a general shape of an object. So for example, a fingerprint, it'll follow basic formations such as the ones here, like an arch, the loop, and the whirl. Everyone has them. If you look on your fingerprints, 99.9% of us will have these fingerprints. So patterns is going to be a specific design or a specific, excuse me. Pattern is going to be a specific design of shapes or composition of shapes in a form within the object. So within your fingerprints, within the arches, the loops, and the whorls, you're going to have these different characteristics, such as a plain arch, a tented arch. Maybe you have some different loops. Maybe you have some different whorls. Maybe an accidental whorl on one and then a central pocket whorl on the other finger. So this is gonna happen when you take a real closer look at your fingers. There's gonna be different ridges and different patterns on the fingerprint that make more specific identification points. So this allows experts to compare and match different evidence from one another, with accuracy. And then for feature persistence is how durable features are over a period of time and when they're under, various conditions. So, for example, if a hammer was used at a crime scene and the hammer wasn't used much after that, the features may be a little bit more prominent and a little bit more identifiable, leading to a match. And then if a hammer was used after, it was used after the crime and it was kind of worn down, it may be harder for it to make a match because the marks at the crime scene may not be as prominent. Um, so in the fingerprints example, the ridge patterns of an individual's fingerprints, they don't change over time, and that's what makes it ideal for it being a long-term identification thing. So, on patterns, while we're on patterns, not all patterns are the same. So there's a difference between unique natural patterns and unnatural repeatable patterns. And it's that the unique natural patterns are formed in nature and they're not likely to be replicated or repeated. Okay, but they are able to regenerate themselves. So, for example, with this little tree stump right here, when you cut a tree, it's able to regrow itself. It'll take time, of course, it'll take time, but it's able to grow itself back. And it won't be exactly the same as before, but it'll able to regenerate itself. The same thing can be seen with the body. When we cut ourselves, we're able to, heal. We're able to, the cells are able to regenerate and kind of heal ourselves. With DNA sequences, they're one of a kind and they're not likely to be repeated. They're unique to us. Now, a natural repeatable patterns are patterns that are made by humans, tools, or machines. So they're man-made. And it can be replicated, but they can also be worn down with use. So with tire marks and tools, we're able to see that with time, they're going to start wearing down. So with tire marks, that's why they say to change your tires often because they start balding. They start losing their tread, their marks. And that, of course, leads to unsafe driving. And then with tools, with constant use, they end up breaking, the manufacturing labels and the marks are starting to wear off and, compared to a new one. So the similarities between the two is that one another is not permanent. Okay, they're both durable and they're both subject to change. And the change can either be done by aging, by being damaged, destroyed, or even faded. And this can happen at a fast pace or a slow pace. So, for example, the clouds, we see clouds, they move throughout the day, they change shape, they change. at a quicker pace than if we were to watch the mountains, the peak formations to change over time. It'll take way too long because it'll be at a slower pace. So, an example with fingerprints with the image below, the fingerprint A, it kind of shows a scar right here, okay? It kind of shows a little scar, it's healed. And then image B right here, it shows 10 years later, the same fingerprint. We have a scar right here, maybe another little cut, maybe a crease. You see some other little, changes, but after the 10-year period, you see some slight changes. So we are able to see these different marks and patterns through different levels of details within images. So the first level of detail shows the basic structure of the shape of the object. So right here, using fingerprints, we're able to see, the arches, the loops, and the whorls of the fingerprints. So the second level of detail shows the smaller features that are within the general pattern from the first level. So within the whorls and the arches and the loops, we're able to see, the different ridge patterns, the different line fragments, the different, characteristics that may be on the fingerprint. And then the third level of detail shows the fine, small details that are within the previous two levels. So in fingerprints, you can look like it would be the pores, how the line shape varies, and any imperfections such as, scars or warts or maybe some creases. Now, all of this is used, all of this evidence and all of this examination is used to make a judgment. So when an expert makes a judgment, it plays a key role in forming a conclusion that two marks may have come from the same source. So to make these judgments, enough information is needed to make sure that it's a true judgment based on the evidence. So experts are going to have to make sure that they are going to consider the facts of the evidence, such as the measurements and the data, as well as consider their past knowledge and experience to conclude whether the two marks come from the same source. So it's going to involve objectivity and subjectivity. It's also going to use three types of logic. So there's three types of logic that are used by forensic experts in comparative science, which is deductive logic, inductive logic, and abductive logic. So these three types of logic are used during examination in comparative science. Deductive logic is reasoning that is based on the general principles or concepts where one can achieve a specific conclusion. So this is typically used during training scenarios, as well as it can help the examiner start with a known fact and apply it to a case. So for example, taking the rule that, if a fingerprint matches on all of the identification points, it is likely to be from the same person, and apply that to a case where the fingerprint from the scene matches the suspect at all points. So one is likely to conclude that it came from the same suspect. Inductive logic is reasoning based on specific observations to create theories or draw conclusions. So this logic is not guaranteed, and it is possible for a chance of error, and it can only be inferred. So an example of this would be using tool marks. So there's an observation that a tool mark was used on a window frame that looks to be from a specific type of screwdriver. So it is likely to infer that the tool that was probably used at the scene was a screwdriver. Now, abductive logic is reasoning based on creating the best possible explanation from the given evidence. So the expert is supposed to start with the fundamentals first, as well as the facts. This would include, the examination of the object, determining whether there are similarities or differences, and whether or not they came from the same source. So this is where the expert can draw the conclusion that the marks came from the same source, or they're different and they don't share the same source. And this is the reference that I used for my presentation. It is a textbook, and thank you for listening to my PowerPoint.